Dirty Scrap Podcast.
Hey Nick, how you doing?
How about yourself?
Doing fine. I was just dealing with some technical difficulties here, but now thank you so much for make the time for being here in one more episode of Dirty Scrap. How
Yeah.
business going? How's everything going?
We're definitely seeing a little bit of a slowdown. We were very
Right,
busy towards the beginning of the year. We were, I mean, for the past basically 2 years, we've been playing catch up. We've been
right.
backlogged. Orders have been on the books for longer than we would even like them to be. But yeah, definitely seeing some slowdowns. Definitely not the new business is definitely slowing down quite a bit.
Right. Yeah, I mean, I was hearing like a webinar yesterday from the Aluminum Association, and they were talking about tariff,
Mhm. Yep, yep,
301 and 232, because it's the topic that is, the trend right now, even though if this been like, I mean, the administration been working on this for at least 6 months already or something
yep.
like that, even more. But in some point, looks like everything is settled down, but it's not. So actually, I was last week in Chicago during a RIMA roundtable show, and they were talking about the same. And it's pretty much that the uncertainty in the market is not allowing the people to move forward. And I think that uncertainty is good and bad because uncertainty brings a lot of opportunities, of course. But doing, that big step in, new investment or new greenfields, even though for these primary guys that they are putting a lot of money on the table, I mean, it is just no one knows what to do and what is happening, and they don't have a clear idea about the future of the market, the pricing, everything. So you are experiencing right now the same.
Yeah, and I think one of the things that we were seeing is very early on, back in February, March, even a little bit before that, there was a pretty good understanding that tariffs would happen. This
Right.
administration has not shied away from that in the past.
No.
So everybody across the board was kind of preparing for that. There were different ways that different companies took different strategies that different companies took to kind of approach and mitigate their impact or get ahead of them and create an opportunity from it. What we saw is there was a large amount of interest in the beginning about new investment, creating new facilities, spinning up, or we got in the recycling industry, reaching. We were reached out to by several manufacturers that were looking to bring some of their recycling and other
Right.
processes in house. Most of those didn't happen. The vast majority of what we saw was they were very interested in doing it. It was a lot of capital to put up front, and then they were impacted by the tariffs themselves. So a lot of the times, the capital that they had or thought they had was no longer available when they were looking to finally move forward with it, and we kind of saw that happen repeatedly. Now, again, this is more or less speculation on our part, but a lot of those companies are public. We saw where the profits were,
Right.
and it makes sense why they didn't have the capital to move forward at that point.
Right. But, I was talking with some people during the show last week, and companies like they are melting scrap and, putting ingots into the market. They said that the last 6 months were great for them, but right now they are
Mm-hmm.
seeing everything is slowing down. That
Yep.
make no sense. I mean, supposed to be. I mean, the goal of the tariff supposed to make more competitive our industry, right, against the third parties overseas because they have a better pricing, more flexibility, and we supposed to have more flexibility right now with the administration. And the tariff supposed to give us at least in the short term, because I don't see in this being a long-term solution for anyone,
Right.
but supposed to give us more competitiveness into the market, so we will have better, profit and more volume. We will be able to put more volume out there. But yes, definitely is something that I don't understand completely, and I don't think no one's know what's going to happen.
Yep.
But for example, for you guys that you have a lot of, let's say, suppliers, in order for you to supply the right solution and
Yep.
keeping your pumps working perfectly with the spare parts and everything, have you seen a lot of impact on your pricing and supplier sourcing?
Yep.
What I'm asking, because I'm working right now on a different company or a different industry that is a gold and silver, and we are working on a project with them. But these guys need a special transformer, and this is supposed to be ready in 10 weeks, and right now it's 23 weeks because all the tariff are impacting, the sourcing of the material. So are you experiencing something similar?
Very much so. And I think, again, to preface this, High Temperature Systems is manufactured based out of Ohio. We like working with American companies, American manufacturers, American suppliers for the vast majority of our
Right.
needs. Even still, those manufacturers or other suppliers may be sourcing internationally. For example, vast majority of our motors inside of the States, you'll see a Baldor motor on them. Baldor hit us with 2 price increases since the beginning of the year. Our refractory sleeves manufactured in America, price increases.
Right.
Our graphite distributed through American companies, sourced globally, price increases off the board if we can get it. And that was another fun thing that we were experiencing is a lot of the manufacturing being done for some of those products is in countries like China, India, and other parts of the world. And
Right.
with the expectation that tariffs would be put on those products, what a lot of companies were doing was getting them in bulk, trying to basically hoard them so that they could supply at a lower price than what they would be post tariffs. So we saw shortages in a lot of those materials, at least in a short term. Fun
Right.
thing with China was, there was the threat of over 100% tariffs on a lot of product. So companies just simply weren't importing. So that just had an interruption in the supply chain where we should have been okay. And those tariffs were never, really applied because nobody in their right mind would pay 135% on
Yeah.
any product
It's freaking
coming
crazy.
coming overseas. So they just simply weren't shipping. I mean, that was the logical thing to do was just wait it out and wait for them to go down, and then keep manufacturing. Don't stop manufacturing. Understand that those are going to go down, but there was that hole because it's not like it takes a day or two for something to go from China to Los Angeles. It takes time to get across the ocean and then through the ports.
Right.
So we saw a pretty heavy interruption in the graphite supply chain because of those tariffs, regardless of the fact that they are now more expensive in total. But yeah, every single component that goes into making a pump is more expensive than it was 6 months ago. There's no getting around it.
How you guys are handling that? You will have two different, let's say, approaches here. The first one is internal approach, right? How do you make this overpricing work for you from the point of view of your company? And how is the customer reacting to this overpricing?
Yeah. So again, we try to get out in front of it as best as we could. So the first
Right.
things that we're doing is making sure that our supply chain is as stable as it possibly could be, that we have a reasonable amount of material at a pre-tariff rate in order
Right.
to.
But at the end of the day, it's something that you cannot handle
Yeah.
100%, right? I mean,
Right.
you can handle it to some point, but
Right.
when you cannot handle and you cannot control it, what are those strategies that you are applying?
Yeah, so the few of them. One is obviously stockpiling is definitely one of the key things, but two, just being smarter with the materials, how we're using it. Making sure that we're getting as much life and value out of each individual component as we can, and working with our customers to say, hey, we could hypothetically change to a different product. It's going to be more expensive, give you these advantages, but just keeping in mind that this might have not made sense before, and maybe it does now, because we were seeing, if you take, a certain percentage of price increase across different materials, it may make sense to do an upgrade to a longer lifespan, either material or size, where it didn't make sense before.
Right.
So just making sure that we're trying to put ourselves in the customer's shoes and saying, okay, we understand that prices are going to go up. There's not really too many ways around that. But just making sure that they're getting the best value, the best approach, and the best kind of bang for their buck that we can possibly give them with those new price points.
Right. I think at the end of the day, everyone needs to be more flexible about what is happening, because
Yep.
everyone is getting the same hit, even though if it's indirectly or directly, hitting by the tariff and
Yep.
the product and the overseas complications that we are seeing here. In order to move the industry forward, we need to be flexible in every
Yep.
aspect of the supply chain, the production and raw material.
Yep.
Saying that, what is coming? How do you can surf this wave that are coming? It's coming just in front of us with all this uncertainty. What are the new strategies? Because at the end of the day, resilience, right? You need to be resilient as much as you can, and you need to be honest and very well communicated with the customer. So what is coming?
Yeah. So, and again, just to preface this shirt's a few years outdated, but high temperature systems has been around quite a while. We've seen a lot of different administrations, a lot of different policies. We've weathered a lot of storms, been through a lot of different economies, up, down, and in between. The key things that we're looking for is just being honest with our customers. We know why prices are increasing. letting them know where our stuff is coming from, what goes into their products, and just making sure that we're making the best product that we can make at the best price that we can make it for. And,
Right.
hypothetically, if we do that, then, it's between us and our competition to, solve their problems.
Right.
But realistically, just keeping that honest and open approach, and, maybe there are new opportunities or things that, if the cheaper materials were getting pushed out of the price range of being cheap, maybe the more expensive materials are making sense. So delving into those more premium materials that may not have been as impacted by price increases, and just looking to evolve and change materials or change processes
Right.
that may have been previously out of the realm of possibility, or it just didn't make sense from a price standpoint, and reevaluating those to say, okay, maybe this makes sense now. Maybe this upfront investment makes sense over the long term.
How easy is to do that, to adjust yourself to this all uncertainty, and how fast you can do it?
Oh, it's definitely not a quick process.
No.
And depending on, what exactly we're trying to change. For example, if we were trying to change, one of the core pump components, there's a lot of unknowns there, right? There's an upfront
Right.
cost in changing the material, retooling, remachining, all the baseline stuff that goes along with that. And, hypothetically, if it's a new material for us, it's a new material for our customers. They're uncertain as well. They don't know what kind of lifespan they'll get out of it. They don't know what their spare parts look like. They don't know anything there. So we're asking, we're taking a risk. We're asking them to take a risk, and times are already uncertain. So it's not exactly an
Right.
easy sell.
What the customer is saying when you ask them to take the risk, are they open to do it, or?
I think they're usually open to do it as long as they understand that we're taking a risk too.
Right.
Approaching a customer and saying, "Hey, shoulder all of this risk," never works out well. So coming to them level-headed and with an approach of saying, "Hey, we don't know if this is going to work. Here's our cost with it that we're going to eat. Here's what we're asking you to do, and try it and give us your feedback and see if it makes sense. If it makes sense, then we'll keep going with it. If not, we go back to what we were doing, and you have to have some skin in the game on both sides. Otherwise, it never works out."
Definitely. Yesterday I was, because everything that is involving all these changes right now looks like it's driving to an opportunity to increase, recycling rates and not let the scrap go out of the US. But yesterday conversation with the Aluminum Association, they were talking about the UVC and the amount that is going to the landfills, right? That for me is crazy. But right now, with all these opportunities that we have here to melt more and make more aluminum for the industry, the UVC metal lost going to the landfills is $1.2 billion a year. I don't understand why. I mean, we are seeing, as you just said, we need to put our skin on the table, right? Everyone needs to have some kind of risk and evolve according to the industry is moving in a direction that it probably right now it's uncertain, but it is what it is. But we want to go in that direction. We are seeing a lot of people trying to understand what's going on, but we want to increase our recycling rates. But even though we are having $1.2 billion a year thrown into the landfill, so it looks to me that it's not easy just to say, okay, let's grow and let's face it, when we don't have the capabilities to do it. So that is something that is crazy to me, and this administration is driving in that direction, but I don't see if the industry is ready to move forward and grow as fast as we want. Now, saying that, let's talk a little bit about the technical point of view of your equipment. And I want to dig in a little bit on the safety point of view, because some of the challenges that I'm seeing here in the US with all this craziness that is happening right now that we don't understand 100% is also inside the processes. I am seeing a lot of companies with a well-known trajectory, during the time, but a lot of the safetiness point of view is not there. So for example, for the pump point of view, what are those safety issues that you are seeing, and how you guys help the customer to handle that in order to not have, any risk of accident or whatever?
Yeah. And this is, a very relevant topic, it seems, this year. And I don't know if you experience kind of the same shift, and again, this is mostly anecdotal experience from my point of view. But when working with pumps, we're in a lot of different facilities, and it seems like the facilities that we're going into now have a very different structure than they did, say, 5 years ago, pre-COVID. And I don't know if you've experienced this as well, but it seemed like when you walked into any foundry, any die cast, or any shop involving molten metal, you had basically the same structure of people. You had that old guy that had been there for 30, 40 years, was looking to retire, and COVID hit, and one thing led to another, and he's no longer there.
Right.
Now you see a much younger crowd that's running the show. And I think you've experienced this as well. And it seems like I'm running into this more and more, specifically, revolving around the pumps. There's very specific procedures of how to bring them up to temperature and safely introduce them to molten metal. But it's not that the new the new crowd doesn't understand that there are processes involved. It's that they didn't even know to look for them, right? So at some point in time, there was a very big shift in who was operating those facilities, and the newer crowd doesn't know what they don't know. And we're seeing this more and more is they didn't know that there was, a manual hidden in a file cabinet from, 20 years ago when when the equipment was brand new, right?
Right.
And, we talked, in previous, conversations, we had talked about, Foundry 4.0 or whatever. The new crowd kind of inherited Foundry 4.0 or Foundry 5.0 or whatever we're on now. The old crowd were beta testers. So for basically everything before that. So they had a very good understanding of the inner workings of all of that equipment, not just the pumps. But the new crowd kind of inherited this automated facility or this highly computerized and basically electronic sensors, everything basically being laid out on a screen for them. And they don't know to look beyond that or elsewhere into the mechanical sides of things because they'd never had to. So specifically involving the pumps, the biggest issue that we're seeing is with the preheat process. And it's just, we had some incidents that we talked about earlier this year. I was recently in a facility that just simply wasn't doing a preheat process. And it was because they didn't know that there even was a preheat process. It's not that they knew about it and were ignoring it. They just didn't know that it existed.
But how? I mean,
right.
and this is not just happening from the pump's point of view. I mean, I am experiencing this from the scrap point of view. They're not making the right, I will say, pretreatment processes. They are just throwing there the material, and sometimes they have some explosions that damage the refractory inside the furnace, but also reduce the aluminum recoveries out of your scrap because you have moisture or it's freezing or whatever it is, and also you are putting in risk your people. So before we dig into the, let's say, way to do things better, do you think it is important to have a bridge between the old ways to make things and the new automatic ways to do it, and how we can accomplish that? For example, from the pump's point of view.
Yeah, and this was always something that I had a little bit of a gripe with. My background is in computers, before I came to the molten metal industry. But there had been a push to put more and more things in kind of this black box kind of scenario, right? Where the operator doesn't exactly see what's happening. They see the input and they see the output, but they don't see the magic, right? And it's that's the problem, right? You can, we run to an old adage, new kids don't know how to drive a manual car. That's fine. We invented a better system. But if their car breaks down and they don't know what a transmission is, they might have a problem. And this is what we're seeing more and more is we had, and most manufacturers are guilty of this. Most OEMs that are developing kind of these automated systems of not explaining exactly how that system works. Right? We made it work and we know how it works, but we're not explaining or teaching that to the person responsible for running, fixing, and maintaining that system. So there definitely has to be a bridge between the new and the old kind of way of doing things, and often that is the manufacturer.
Right. Who is responsible to build that bridge?
That's a good question.
Is the company that is buying the equipment that is more sophisticated, or is the supplier, the OEM, that needs to be aware enough to understand that it's something brand new, it's a different approach, and you need to match what the old people use, not the old people, the old practices were doing with the new ones? Who is the responsible, let's say, key guy here?
Yeah, I think they both have to be. I think the right answer is they both have to be. I think it's up to the manufacturer to realize kind of what the experience level is with the people that you're working with and what they're capable of, and for the companies to have good, solid foundations in documenting processes and procedures and seeing where the differences are and how they used to do things and how they have to do things now.
Right.
And I think that's always been a problem, is that training, that sharing of information, that those key points of data, everybody always jokes about we made a manual and nobody ever reads it. There's acronyms for
Right.
that, but
Yeah.
so um,
I
yeah,
think
but it
one of the
definitely has to
issues,
be both
both.
sides.
Right. I think one of the issues that I'm seeing in the industry is the industry wants to move forward so fast that they are not taking the time to say, hey, this is the in between from what is used to be done and what needs to be done right now. And also, I think everyone is moving super fast because we are seeing this lack of labor. And
Yep.
obviously, with the um, how can I say it without making a mess here, with all these immigrant policies right now, that accidentally
Hmm.
the U.S. industry falls into illegal immigrant dependency in some point.
Yep.
It is what it is,
And
and
I
you don't
think
need
that was never really a secret, right? You
exactly
go to any
exactly
facility, in especially in the southern part of the United States,
right.
and that was apparent walking in there. Less apparent in the areas that I work in, more apparent in the areas that you work in. I think it just is what it is, and it had been that way for several years, and it was kind of an accepted fact.
Right.
That being said, and especially for us, just hiring in manufacturing in general has always been difficult. It seems like it is easier now than it was 5 years ago for American citizens to want manufacturing jobs, but it's still it's not like every other person is going down to work at the Ford factory. It's
Yeah.
not the way that it used to be, right?
No.
American manufacturing isn't a job that a lot of people, when they're in high school are striving to get into, right? It isn't one of those dream job kind of deals, but
Right.
realistically, it's a good, career path for those interested in it. But yes, the current administration policies are, potentially impacting, the labor force inside of the aluminum and foundry industries in general.
Right. And everyone wants to just solve this with automation. Okay,
Right.
okay, let's put a lot of automation here, but it's not easy because at the end of the day, you are dealing with some, let's say, procedures that you need to keep in mind in order to make the good job inside your facility and not just go and push a button and say, oh, okay, everything is ready. So,
Yeah.
talking about what needs to be done in order to not or to avoid these issues, what are the good practices that you can recommend, for example, from your point of your pump manufacturing point of view?
Yeah. Um, I mean, it's definitely not a clear and cut process or procedure, but the biggest things that we're seeing, and the good news is pumps really aren't that complicated, right?
Right.
Fundamentally, there's a couple things that you have to, keep them keep stuff
They are
out of them.
complicated. They are for me. They are complicated.
Yeah, so the obviously the fine details are complicated. The fundamentals are not. You keep stuff
Right.
out of them. You keep them clean. You keep them keep the temperature down, and for the most part, they'll run reliably. What we're seeing is there's a heavy push, for automation of how to use the pumps. It gets we have some mixed feelings about it because they're operating a pump is an inherently it's safer than a lot of alternatives, but it's not inherently safe. Right, we are
Right.
taking metal from one place and putting it somewhere else. There's things that can happen in that process, touching back on the safety side. So we had always liked putting that in the hands of a person to say, okay, person pushes a button, pump operates, person stops pushing a button, pump no longer operates. Now, how to translate that into an automated system with eyes and ears and ways to see if anything's going wrong is a very difficult process, right? When we talk about, the automation required for a foundry, we're talking a lot of different sensors and measurements and reading a lot of inputs. But,
Right.
going back to the car scenario, your check engine light comes on. What's the first thought that runs in your head? It's probably a sensor, right? And then we
Right.
take those same types of sensors and same, types of approaches, and we put them next to 1200 1300 1400 degree metal, and all of a
Mhm.
sudden the electronics don't want to do what they're supposed to do. So it's not only how do we automate those processes, but how do we automate the failure of those automation processes, right? What do we do when one of those sensors malfunctions? How do we know it malfunctioned,
Right.
right? and how do we relay that information to the end user in a way that makes sense, where they know where to look?
Yeah, at
Those
the
are
end,
the
I think it's a
challenges that we're seeing.
combination. Exactly, it's a
Yeah.
combination because I think what I am seeing in the industry is mostly with the young people that right now, as you just said, after COVID hits,
Yep.
we are seeing more young people involved into the industry with certain kind of experience, but not with the 30 years experience that
Yep.
they used to have. So for me, it looks like they are thinking about automation that is 100% automatic. And it's
Yep.
not like that. We are talking about metallurgic here, right? It's
Yeah.
molten metal going from point A to point B, and then you need to cast it, and you need to be aware of the shape and a lot of different things, and temperature
Yeah.
control, flow control, and it's not 100% automatic. You will
Yeah.
always need human people going there and checking everything. So, from the pump point of view, what are those key points that you need to be aware, even though if it's not 100% automatic or it's just part automatic? What are those point of view that, or the the key points that you need to be aware when you are using a pump in order to have more, extended useful life, or not to blow your metal out of the furnace and damage something or hit some people or whatever? What are those points?
Yeah, so there's kind of two. The biggest thing is you got to keep it clean. Just ensuring that your furnace maintenance is good, that you're drossing, that you're keeping that pump wall clean, free of debris. That's really the biggest thing. The pumps are expecting liquid. If they hit solid, bad things happen.
Right.
And that, not necessarily a safety point, but it will damage the pump, or has the potential to damage the pump. And then you have to do extended maintenance, and then you're bringing that automation down, right? Because now
Right.
you have to have a person or people going to work and maintain the system.
Right.
The second is just careful consideration of kind of how you are moving metal from point A to point B. Just the kind of the limitations of the pump, the limitations of the system, and making sure that the pump can never output more metal than the system is capable of handling is a big
Hmm.
one. We've seen a lot of cases where a level sensor is used to kind of control the way that the pump is operated to try and maintain a consistent flow from one furnace to the other.
Right.
Problem with those level sensors is, again, they're sensors, right? You put them above, the molten metal bat to read the molten metal level. They're exposed to quite a bit of heat. If they fail, one of two things happens: they get no reading, or they read that the furnace is empty. Well, when the furnace is empty and the pump kicks onto high gear and overflows your launder, we have a problem.
Right.
So it's careful engineering of kind of multiple steps of that process, or at least putting guardrails on how that pump is able to operate. Saying that the pump is never able to operate at a level that exceeds all the other equipment is really the biggest safety factor to introduce.
Right. And what are the risks that you are getting from that approach that you said, okay, I will just overload the pump capacity? What are
Yeah.
the risks that you can
Well, I
face there?
mean, yeah, the most common thing that we see is overflowing a launder or another inlet, or we're not getting good data back from the other end of the system. We have the input data from where we're moving metal from, but not where we're moving metal to.
Right.
And then something is happening downstream that the pump doesn't see or isn't aware of. And then, you're playing the real life version of the floor is lava. And that's never a
Right.
good thing to do in a facility.
That just remind me my kids when
Yeah.
before the slab. Yeah, and it is funny because I remember that once I went to this very well-known die casting facility, and once I got there, I'm from Colombia, and not even in Colombia I saw something like that, metal overflowing everywhere, because they don't have the right way to do things, and also they
Yeah.
have certain molten metal capacity that is not matching with the die casting machines, so they
Yeah.
prefer to overflow the metal, instead of having a different approach and recycle the metal or doing whatever it is. Why
Yeah.
is that in the US? What do you think is no one is not no one, I don't want to generalize, but what do
Yeah.
you think some people that been in the industry for a long time, they are not taking care of that? The metal is expensive.
Yeah, yeah, and I think there's a couple different reasons. I think one of the biggest ones is, right, when you look at a system and let's say you've got a foundry with 100 different parts, right? You go
Right.
and you upgrade one piece, and then next year's budget comes along, you upgrade another piece, and then you upgrade another piece, and eventually, when you started, you probably had a well-balanced system. But now you've gone, you said, hey, we need more capacity here, let's add it. We need more capacity here, let's add it. And there are things that are in between there that either got ignored or neglected. And we were both in a facility that, had this problem of, it seems like they had pushed too far towards one goal that they neglected the fundamentals. And this comes back to, bad processes and procedures. And it seems like old hat versus new hat, there was some miscommunication about, some important things. We were seeing metal being transferred at over 1,500 degrees Fahrenheit, which is highly unusual for the industry.
Right.
It's a very, very hot transfer. And just, it seemed like they were trying to compensate for a lack of one equipment with the, oversizing of another. And and you'll see this a lot in older facilities of some equipment's brand new, some equipment's been around for 100 years.
Right.
That mismatch is often a big part of the problem. So that, it's kind of hard to balance a system if you've got, brand new components on one side and a system that was engineered before computers existed on the other.
Right. Right. From the maintenance point of view, and not just the maintenance point of view, but to start the process again with the pump, because I think it's also the maintenance is very important also from the safety point of view, but not also the maintenance, not just the maintenance, sorry, but also the way that you insert your pump to start the process again, because I am seeing a lot of people that just throwing the pump there and boom, goodbye. Right. So what are those key points from your side that you can recommend when people are using your products that they can obviously perform better?
Yeah. So the kind of key points to be concerned with is there's two different things that we're doing when we're preheating the pump. The first one is we're driving moisture out of components, and this is by far the most critical for the kind of safety concerns. And this varies from pump to pump, from design to design, from manufacturer to manufacturer. I mean, we're using, graphite based pumps for the vast majority of our pumps. A lot of our competitors are as well. And a lot of the physics is the same no matter whose pump you buy, right? We can't change those laws. So the first thing we have to do is we have to get the moisture out of the pump. And this has to be done before the pump is allowed to touch the molten. The problem is the graphite likes to absorb water. As soon as you introduce that into the molten metal, you create steam and you have an explosion. And that's kind of the risk that we've been seeing. And again, this is just, you have to insert the pump slowly. We have different timelines depending on, the pump and the metal that you're operating in. And aluminum, that process should take, if you're doing everything correctly, for the vast majority of our pumps, between an hour and 15 minutes and 2.5 hours on some of our larger pumps.
Oh, wow.
And it's a very long process. And the reason why and again, those are our recommendations, how we would do things if we were inserting the pumps. And that's because for us, that extra hour or two is worth the safety of everybody involved. Right.
Right.
And, we would like to believe that the companies believe that as well. But yeah, we had been in, I was in another facility just a few months ago. But yeah, they leave the pump, hanging over the furnace. When they're ready to insert it, they just drop it down. Whole process takes 5 minutes. That's not that's not how you want to be doing.
That's not the way to do it. No, but two things here, because I was talking with some people in the industry as well. They had this issue before, and the way that they are thinking is, okay, we don't want to spend 2 hours, 2 hours and a half during this process. That I think is something that you need to take into consideration, because it's better to spend 2.5 hours doing this process that send someone to the hospital and getting troubles.
Yeah, and that's the reality of the situation, right? Is if you do this wrong, there's a very high likelihood that somebody gets injured, because when you're lowering a pump in, it's not like you're doing it from the next building. You're standing next to it.
Exactly. And this is something that I don't see people understand it. That is not 100% way to just drop the pump automatically, because you need to, center the pump and everything. And they said, okay, some guides into the furnace. It's not easy to do it. Now,
go ahead. Sorry.
And saying that also, they are thinking about just preheating station. A preheating station can be a good option, yes, definitely, but this is not avoiding the point that you need to have the perfect, timing to drop down the pump, right? So,
and the way that we like to approach that is the preheat can solve at least part of that problem. You can drive the moisture out of the pumps using a preheat station. The second part that I didn't really touch on during that preheat process is the ceramics used in the construction of a pump are typically very high hardness, very abrasion resistant ceramics, but not necessarily very resistant to thermal shock. So those high wear surfaces you want to introduce slowly so that you don't crack like glass.
Right.
So
Right.
that's the problem with the preheat station is you can get the graphite up to temperature enough to drive the moisture off, but you still need to slowly preheat up to the operational temperature of the pump so that you don't shatter the ceramics.
Right. So it's not like you are just putting the pump into a preheating station and then
Mhm.
you put it right away into the molten metal.
Right.
Saying that, how far can I go on a preheating station where I am preheating a pump in order to, have as much as close the temperature in the
Yep.
pump to the molten metal?
Yeah. So no matter what, you want to stay under the oxidation temperature of the graphite. That's the most important thing. So yeah, definitely below 600 C. And you probably want to be well below 600 C because depending on how you're heating that pump, you may be introducing, an oxidizing flame or something like that
Right.
to the pump. You just want to make sure that that's not in direct contact with the graphite. It's also one of the reasons why we don't recommend using torches to heat graphite or try to melt aluminum off of the
Right.
pumps themselves. Because that flame can be oxidizing and damage the graphite prematurely, which is not what you want to have happening inside of your preheat station. So no matter what, there's a hard cap limit at that. We typically don't recommend preheating up to that high of temperature. What we recommend doing is somewhere in the neighborhood of about 300 degrees Celsius, just to make sure that the pump is moisture free. That is the longest part of the preheat process. And it's also the kind of most efficient way because typically if you're building like some kind of oven or a preheat station, or if you're purchasing one from us, it isn't as well insulated as your furnace itself. Obviously, we're not talking about hearth temperatures inside of these preheat stations. And the lower the temperature we keep it, just the more efficient it can run. So keeping in mind that if you want your pump to be ready to go 24/7, 365, then you're going to be spending some energy to do it, right?
Right.
So that's the trade-off is, you want to balance those energy costs and efficiency with the cutting down of the preheat time. The good news is if you have your pump preheated to the point where there's no moisture present, you've at least, for the most part, eliminated the safety risk. And this is the biggest point for us, right? If you can get the moisture out of the pump, then now we're just onto the issue with the ceramics cracking. And the good news is at least it is much safer for the ceramics to crack than the pump to explode. So for us, this is where we are comfortable cutting down that preheat time with the preheat station. But you can never completely eliminate it, right? Because we have that barrier between oxidation temperature of graphite, operational temperature of your metal, which is, we're talking 600 C. Plus, now you have the time where you've removed it from the preheat station, hanging it over the furnace, getting it lined up, and then lowering it down. And the materials that we're using, graphite, silicon carbide, all of those, very high rates of thermal transfer. So they cool down very quickly once you bring them into the air. So that ambient temperature that you have going from your preheat station to over top of your furnace, which again, if you're preheating to 600 C, your air temperature above your furnace is not 600 C.
Right.
So you're cooling the pump down during that whole time, which means you just lost your energy efficiency from preheating it to that point. So the good news is that, it's not going to absorb moisture during that time, but it will cool down. So that's why we typically recommend that 300 C kind of neighborhood. Now, as far as automating that process and lowering it down, I'm sure there is a way to do it. We also know what a pump well looks like after a pump has been operating for, a year or two inside of there. And again, it's, do you want to do the maintenance to keep all of that clean and operational, during that time, or is it easier to just lower the pump in? And again, this comes down to, well, we can make the pumps last longer and cut down your maintenance, right? Let's focus on some of those fundamentals before we're worrying too much about fully automating that system. Because again, these pumps are fragile. You do have to take a lot of care when lowering them down. And that is the most likely place for them to get damaged, is that insertion and removal from the pump well.
So it's not during operation, it's not removing, it's put it into the furnace.
Yep.
How do you guys communicate these type of approaches to your customers? Because at the end of the day, what I'm seeing out there is they are not doing this, and I am not talking about your pumps, but other
in general,
let's say branches, yes, in general. And I am not seeing the people going and doing these approaches or practices during the processes, and then they say, "Oh, mechanical pumps are not that good." because they're damaged too fast. Oh, how you damage the pump? Oh no, when I was installing the pump. Come on, how you
Yeah.
do it? So how you guys communicate these, and how do you make sure that the or your customer is aware that this is something important that they need to do?
Yeah, I think the thing that we're trying to do is, especially for brand new customers, we're trying to get one of our team members out there to run through them with the installation. Usually spend a day or two out there going over the maintenance, the care, the operations, the installations, the rebuilding, and all of that with their team on
Hmm.
site with the pumps in operation, and
Right,
just kind of walking them through how everything should be done. Basically holding their hand through that whole process so that they understand what is and isn't important, what they do and don't need to look for, all of those sorts of things. But it really requires somebody familiar with how it should be done going out there and training them. I think there
right,
have been a lot of cases where we've seen issues arising, and it was just it was poor training, because one of our team members was not involved. They had either stated that they were comfortable with it or through a distributor, and there was some very important points missed. And that's what we see is it really requires the manufacturer to be out there and walking them through what matters, because we can give them all of the information, but if they don't know what's
right,
important and what's not, then they're not going to really care about it. So
right, right.
just
That
making
makes
sure that we're
sense.
and I think that the customers that we've gone out to and done that training with have ended up being very successful with it. I think a lot of the times it is a little bit more tedious. We are going to talk a lot, and there
Yeah,
may be things that
right.
you do forget after a couple years of operation. But we try to make sure that those fundamental things, especially the safety side, are well understood by all team members.
Right. I think communication is the key here.
Yep.
Nick, to wrap up this episode, what is coming? What we can expect from high temperature system in the industry? I know that you are very involved into the zinc and
Mhm.
aluminum operations right now. It is possible for you guys also to start looking to deal with other materials with higher temperature processes. Are you also doing any kind of redesign on your equipment
Yep.
in order to be more, I don't know, or bigger capacities or more efficient? Uh, Tell us a little bit more about what is coming.
Yeah, absolutely. So yeah, high temperature systems, and this is my primary role, is heavily invested in the R&D side. So we are looking at new materials for not only longer lifespan of our existing metals, but also breaching into the markets of higher temperature metals, specifically those copper based,
Hmm.
is a potential for us coming up.
Right,
Additionally, we are developing at least one new type of pump, just in general. It is a pump that has never been introduced commercially to the market, and stay tuned on that one. You'll probably receive a PDF here shortly. But that one's for mostly internal use at this point in time.
okay,
And yeah, just a general improvement. The good news is the again talking about the new crowd that we're working with nowadays. We do get a lot more feedback on our products and taking into consideration, some changes, a lot of people had done field modifications, and those are being reintroduced as part of our base models of pumps. And
right,
I think there's been a few key places in the market where typically, and again, this is working with the companies that are trying to internalize a lot of processes. We're
hmm,
seeing a lot of things being done on smaller scales than we were being seen before. We're talking, lower chip melt rates, smaller furnaces, all that sort of stuff. So taking some of our features from our flagship pumps, our screw together cementless designs, our easily removable and interchangeable parts, and introducing those to smaller and smaller footprints, to make it easier and more approachable for those facilities that had never worked with pumps before to be able to
right.
do that maintenance on their own.
Yeah, and that will give them the opportunity to have better recycling rates or melting rates, right? At the end of the day, you
Exactly.
are doing some flexible approaches to the industry to give those guys that don't have the volumes to also being able to have better approaches and efficiency out of the process, right?
Yep. Yeah.
That's a great approach. So, Nick, definitely it's always great to have you on the podcast. Where the people can find you if they are looking for some good pumps?
Yeah, so hightemp.com is our main website. If you would like to schedule a meeting, talk about your application, we've got contact us form and actually a Calendly link where you can literally just click it, set up a meeting with me. I'll give you a half hour of my time, no charge. But yeah, that's primary way to reach us.
No charge is good. It's always good. Well,
Yeah.
Nick, thank you so much. I really appreciate your time. I really enjoyed the episode, and I mean, it's going to be very insightful for the people that is out there, looking for more information about how to make things better and how to have better, let's say, useful life out of the equipment that they are using right now. So I really appreciate it.
Yeah.
Thank you so much. And well, once you are ready to release this new pump, let us know. Maybe we can do an episode,
Yeah.
to launch this new pump and understand the characteristics and everything.
Absolutely. Yeah. I'll keep you posted on that one. And again, thanks for having me.
Oh, no,
Dirty
thank you so
Scrap
much. Take care.
Podcast.
No problem. Take care.
Bye-bye, guys. Take care.
Bye.